my work on the concepts of physics, various topics, random topics. So let's begin. Here is the indicator diagrams for pressure and temperature for water itself. So this point corresponds to the triple point of water, and this is how things varies. So this is the triple point of water, which is at 611 Pascal and at a temperature 273.16 Kelvin. And in this state, the water is in solid state, that is ice. Here it is in liquid state, and here it is in vapor state or the gaseous state. And you see the intersection of this point, solid and liquid. It determines the freezing point. Liquid and vapor, they intersect at what point determines the boiling point. So there is a concept over here that what is effect of increase in pressure on the freezing point. So you can see that here, if we increase the pressure, you can see that this coordinate gets shifted to the towards the lesser values. So we can analyze that if we increase the pressure, then there is a corresponding decrease in the intersection point or the freezing point. So we can say that more the pressure, lower has to be the uh, freezing point or the melting point. Whereas if we increase the pressure, you see, if we increase the pressure, then the boiling point will increase on increasing the pressure, or you can say that more energy will be needed to make water convert from liquid to the gaseous state. So this is analysis for that. These are called the indicator diagrams. So this is a proper schematic representation of this. Now here we have another question on the calculation of heat flow through a slab of ice. So you just use Fourier's law over here that heat is K delta T by delta X. There are calculations involved on that. Now there is another discussion on another question. There is a system of four charges, and we need to calculate the work done. So work done is final minus initial potential energy. It is work done by the external force. So if we analyze the potential energy, so there are six pairs for them. We calculate potential energy for each pair, and initially they are at infinite. So potential energy here is zero. So the work done after calculation comes out to be this much. Now there is another discussion video on the concept of electrostatics. So electrostatics is about electric charge and at rest with respect to observer. So electrostatics is about all the observations which were made by an observer according to whom the charge is at rest. So electric charge, now coming to the point of electric charge, it is something by virtue of which bodies tends to repel each other. Now there is another discussion on the concept of let's say centripetal acceleration. We know that it's equal to v square by r, and in the question centripetal acceleration is given as a function of time. From here we need to calculate the speed, and from speed we need to calculate the instantaneous power, which is f dot v. So f dot v ultimately will lead to mk square r square t. This question has been asked in PYQs of NET, so this is how we can be done. Another discussion is on X-ray. X-ray are of two types, characteristics and continuous. So if you draw the intensity time graph, you see a curve like this. So the peak here represents to the characteristic X-rays because their frequency depends on the atomic number of that particular X-ray. And this continuum is about the continuous X-rays, which has got a certain minimum wavelength. So this is how things can be analyzed. Now we have another discussion on Wien's law, which is about maximum spectral emissive power. So if we observe the heat radiated by any body, then it has got a maximum spectral power at a certain specific wavelength, which we call as the lambda max, and it is inversely proportional to the temperature. So larger the temperature, it will shift the wavelength towards the smaller fraction, or we can say that larger the temperature, smaller will be the wavelength corresponding to maximum spectral power. So in this graph you can see that here T2 is greater than T1 or T1 is less than T2. So if T1 is less than T2, that means corresponding to 2, T1 is less than T2, we can analyze from here that here this axis represents lambda. So here we can say that lambda corresponding to graph 2 is larger. So that means uh, T2, this is I have wrongly perceived. I think lambda 2 is greater than lambda 1. So we can say that T2 will be less than T1 or T1 will be greater than T2. This is the analysis that we can make out. Now here is another question on the basis of rotation, that you take a rod from the horizontal position and move it, just release it from rest. So we have to calculate the net torque. So what we use is we use that the net decrease in potential energy is equal to the rotational kinetic energy. So its center of mass will be at a height of, let us say, from here L by 2 from the ground. So decrease in potential energy is equals to the increase in kinetic energy. This concept we can use. Now there is another discussion on a question based on capacitance. So we have to find the equivalent capacitance between the 2 points. Let us say this is point A, this is point B. So these three are in series, so equivalent will be 10 by 3, and here 10 will be in parallel to that, so the equivalent will be 40 by 3 microfarad. Then we have another discussion on electric field. It's a vector quantity. It's the definition of electric field, which is given by limit q tending to 0 force by charge. Then we have three cases. Force is equals to QE. So if Q is positive, force is parallel to E. If negative, force is parallel to minus E. And if Q is 0, force is 0 over here. So these are the directions corresponding to the forces. Next is neutral point. From this discussion, we can analyze is that the neutral point charge does not experience any force in electric field. Then we have certain questions based on dimensions of electric field, which is force by charge. So after calculations, we have m1 l1 t minus 2 q minus 1, and as per electric field as a unit is concerned, it is force by q, which is newton per coulomb or volt per meter or joule per coulomb meter. So these analysis we can make. Well, here is another education psychology video on optimal physics for JEE NEET. So these are the points. What is so special? It is optimized information, mind memorized, optimal learning by master question based on pattern, NCRT line-to-line discussion, complete VYQ discussion, mind training programs for effective performance. So then we have some worksheet based on momentum. So momentum, we have certain properties like it's denoted by this. It's a vector quantity parallel to instantaneous velocity. Then we have dimension of momentum, SI unit, CGS unit, then magnitude of momentum, graphical analysis with mass, various analysis for different graphs, kinetic energy as a function of momentum, as a function of mass. Then we have average force and calculation of average force based on the graph, then variation of theta and various possibilities for forces. Then we have concept of impulsive forces. Then we have a discussion on Wien's displacement law. So this is a spectral emissive power versus lambda graph, and this has got a maximum at a certain frequency wavelength, which we call as the lambda max. And Wien found that the product of lambda max and temperature is constant, which we call as the Wien's constant, which is 2.89 into 10 is to power minus 3 meter Kelvin. So we can say that lambda max is proportional to 1 by t. So if we draw graph between lambda max and t, that's gonna be a rectangular hyperbola, whereas graph between lambda max and 1 by t will be a straight line. So this is the analysis that we can make. Then we have uh, the discussion on equivalent thermal conductivity of rods. So there are two sources maintained at T1, T2, and there are two rods K1, L1A, K2, L2A. So the equivalent here is K equivalent L into A. So these two are in series, so we calculate the R equivalent as shown over here, and from here we can equate that to the K equivalent. So after calculations, K equivalent comes out to be this much. So now there is another case in case of parallel connection. So the resistances are in parallel. So first we find the equivalent resistance. Then using the concept of equivalent, we can say that K equivalent will be K1 plus K2 by 2. Then is a derivation of Newton's law of cooling. Suppose a body is at a temperature T and surrounding it at T naught. So the body will absorb heat at the rate this and it will release heat at a rate this. So the net power radiated comes out to be this. Now net power radiated can be written as dH by dt. So dH will be minus ms into dt. dt is change in temperature. So we equate the expression, we have this thing. So we have the differential equation like this. Now we take T naught 4 as common. So we get dt by dt is minus sigma here, T naught 4, T by T4 minus 1. Finally we get this expression. Now we write T is equals to T naught plus delta T. So from here we get dt by dt is minus sigma this thing, and T is T naught plus delta T raised to power 4 minus 1. So this can be simplified to 1 plus delta T by T naught power 4 minus 1. Using binomial, we can expand it like 1 plus nx. So that will be 1 plus 4 delta T by T naught minus 1. We subtract it out and finally we get this thing. Now we get this as minus K delta T. This is the Newton's law that rate of cooling is proportional to the temperature difference. So this term can go over here. Now we write delta T is T minus T naught. Then we integrate the above expression from T1 to T2 and 0 to T. And after final calculations, this is the result that we have, that T2 as a function of time is this thing. If we analyze the graph, that will be exponentially decreasing curve like this. So initially temperature will be T1 and after a long time the temperature will become equal to the temperature of the room, which is T0. So this is we can analyze. Now we can say that power is proportional to T4 minus T04. So if the temperature of the body changes, so we can compare the two powers as P2 by P1 is T24 minus T04 by T14 minus T04. Here T should be in Kelvin. If it is in centigrade, add 273.15 to as to convert that into Kelvin. Next we have a discussion on modes of heat transfer. So there are three modes: conduction, convection, radiation. So conduction is where material medium is needed, convection in material medium as well as gravity, and radiation is in the form of EM radiations, which is the fastest mode. There we have Fourier's law, which is about heat transfer through a conducting rod, which is maintained at certain temperature difference. Then we have coefficient of thermal conductivity, various concepts related to thermal resistances, various cases related to them, and finally we have graphical variation of temperature as a function of the x coordinate, then temperature of the interface and various cases related to that. Then we have another discussion on change of state, so which is either melting or boiling. So melting is concerned with solid liquid and boiling is concerned with liquid to gas. So there are certain points related to melting, point of ice, boiling point of water, effect or increase in pressure. So with increase in pressure, boiling point increases, freezing point decreases, and with decrease in pressure, boiling point decreases and freezing point increases. So this can be shown graphically by the phase diagrams of water. So here on y-axis we have plotted pressure and on x-axis we have plotted the temperature. And as you can see that there is a point at which three forms coincides. So water exists in three forms at this point, which is called the triple point of water. And this is having a coordinate of 611 Pascal, which is very low pressure, and the temperature corresponds to 273.16 Kelvin. Now in this part the water is in solid state, between this curve it is in liquid state, and here it is in vapor or gas state. So the intersection of solid and liquid forms melting point or the freezing point. Intersection between liquid and vapor corresponds to the boiling point, and intersection between solid and vapor correspond to the sublimation point over here. So we have these points, and the variation can be seen that if we increase the pressure, you can see that if we increase the pressure, then we can see that this point at which solid and liquid intersects, this decreases. So that means with increase in pressure, uh, freezing point will decrease. Whereas if we observe this curve, so the intersection point over here corresponds to the boiling point. So we can see that if we increase the pressure, we have to move towards the larger values of temperature. So with increase in pressure, temperature, boiling point will increase. Now do the reverse thing. If we decrease the pressure, so graph has to be shifted like this, and we can see that temperature will decrease. So with decrease in pressure, boiling point will decrease. Whereas with decrease in pressure, you can see that here the temperature will shift towards larger value, freezing point will increase. So this is explanation of this, and these results are obtained by doing experiments a number of times. A number of scientists were involved, and this is the final outcome of the result. Now we have discussion on ideal gas equation, which is PV is equals to nRT. Now the condition that when a gas behaves like an ideal gas, so it behaves as an ideal gas when temperature is high and pressure is low. Then we have certain laws like the Boyle's law, graphical variations of pressure and volume, analysis of the graphs, various graphs related to two or more gases. Then discussion on charge law, then analysis of different graphs, different possibilities, different angle variation, then Gay-Lussac's law. So these are the discussions. Then we have another discussion on some questions based on calorimetry. So these are the questions, basically ice stream problem, and in which the concept is heat required given is equal to heat taken. So there are discussions on these points. Then we have another discussion on a specific heat and problems based on calorimetry. Concept is heat given is equal to heat taken. So here the concept used is heat taken is ms delta T, which is equivalent to W SW delta T. W is the water equivalent and SW is the equivalent is the specific heat capacity of water. So there is a question that I said minus 30 get converted into steam at 140. We need to find the total heat. So let's proceed systematically. Firstly, ice at minus 30 will be converted to ice at 0. Then ice at 0 will be converted to water at 0. Then water at 0 will be converted to water at 100. Then water at 100 will convert to steam at 100. Then steam at 100 will correspond to steam at 140. So there are 5 steps involved. So the net heat will be the sum of all of these. So delta Q1, delta Q2, delta Q3, delta Q4 up to delta Q5. If we observe things graphically in temperature versus time graph, so the graph will be like this, comprising of A, B, C, D, E, F curve. So if we observe the AB graph, it corresponds to the conversion from ice to water in this state. Then let's analyze points graphically. So AB corresponds to the situation when ice changes temperature. Then BC corresponds to melting, and you can see here temperature does not change. Then CD corresponds to water changes temperature. Then the part D, this corresponds to water gets converted into steam. And then part EF, when temperature of steam increases from 100 to 140 degrees centigrade. So this we can analyze. Now there is a question that 100 gram ice at 0 is mixed with the different masses of water, and we need to calculate the equilibrium temperature, mass of water at equilibrium and mass of ice at equilibrium. So let's begin with the solution. So first of all, let's find out the maximum heat available from water. Obviously ice is at lower temperature, so water will provide heat to the ice. So let's calculate the maximum available heat. So it comes out to be ms delta T, and after calculations it's about 8000 calorie in the first case. Now the delta Q, heat required to melt ice, is also 8000. So that means complete ice will not be able to melt, because it's just the heat is just sufficient to melt the complete ice. So we can say that there will be no energy left to increase the temperature. So we can say that equilibrium temperature will be, sorry, here in this case ms delta T, it will be 800 calorie, not 8000. whereas heat required to melt the ice is ml, which is 8000 calories. So complete ice will not be able to melt, obviously. So the final temperature will be 0 degree, and mass of water at equilibrium will be 10 is the mass of water over here, and plus the mass of ice melt. Now mass of ice melt can be found using ml is equal to 800. So from here we can calculate that mass of ice melt is also 10 gram. So total mass of water will be 10 plus 10, which is 20 gram. Now is mass of ice at equilibrium. So 10 gram ice melt. So the mass of ice left will be 90 gram. Now another question is 100 gram water at 80 degrees. So from here delta Qmax available will be ms delta T, and after calculations it comes out to be 8 kilocalorie. Here it is also 8 kilocalorie. So complete ice will melt in this particular question. So if complete ice will melt, then we can say that final temperature will be 0 as complete ice has melt, and there is no heat is further available. So water will be total mass will be 100 plus 100, so that will be 200, and ice left will be 0. While in the third case we have maximum heat available as 12,000. So 8,000 is used for melting the ice completely. Now still 4,000 calorie heat is available, so which will increase the temperature. So the final temperature in this case will be T. Now we again have to design the solution for temperature T, not for 0. So from here we can say that heat given by water will be 150 into 1 into 80 minus T, and heat taken by the ice will be 8000 plus ms delta T. So from here there are calculations involving temperature which will give result for 16 degrees centigrade. So this is how we can do the things. Now there is another discussion on thermal expansion. So suppose a rod is given which has a length L at a temperature T1. We increase the temperature to T2 and length becomes L plus delta L. So experimentally it is found that delta L is equals to L alpha delta T. Here alpha is the coefficient of linear expansion which has dimension Kelvin minus 1, SI unit Kelvin minus 1. Now there is important discussion that sometimes there is alpha 1 is given in centigrade inverse and Kelvin inverse. So in this case alpha 1 will be equal to alpha 2. While if it is given in centigrade scale and Fahrenheit scale, so we use the result that delta TF is 9 by 5 times delta TC. So from here we can say that alpha 1 will be 5 by 9 times alpha 2. So this is how things can be analyzed. Yeah, this one is whoever it is, Mr. India, brother. I'm especially dealing with JE and NEET physics. So if you want to learn that, you are most welcome. But if you are not interested, then look for the corresponding videos. Look for the videos which are of use to you. I'm here dealing with JE and NEET physics. So if that is your subject of domain, most welcome, my brother. Otherwise, don't waste your time. Just look for the relevant videos on YouTube. Thank you. Have a nice day. Well, another question is finding time period of a simple pendulum. So this is 2 pi root L by G. So if we calculate the changes involved here, so here we have delta T by T is half delta L by L, which is half alpha delta T dash. So these are the corresponding terms, like delta T is change in time period, T is the original time period, delta L is change in length, L is original length, delta T dash change in temperature, this is fractional change in temperature. So this is how we can relate to it. Now there is an important concept analysis during summer and yeah. So here we have analysis for summer and winter. So during summer, clocks become slow or they gain time, and during winters, they become fast and they lose time. Now there is another relation between true value and scale reading. So the relation is true value is scale reading into 1 plus alpha T2 minus T1. So here T1 is the temperature at which scale gives correct reading, and T2 is the temperature at which reading is taken from. So clearly if T1 is T2, true value is scale reading. However, if T2 is greater than T1, then true value will be greater than the scale reading. And if T2 is less than T1, then true value will be less than the scale reading. Now there is another concept of now we have another discussion on variation of density of a liquid with temperature. So density varies as d2 is d1 upon 1 plus gamma t2 minus t1. This is simplified as d2 is d1 1 plus minus gamma t2 minus t1. And the concept is on heating generally volume increases, density decreases. Some exceptions are of water, because on heating water from 0 to 4 degree volume decreases and density increases, and it's because of internal hydrogen bonding, and it has maximum volume and minimum volume and maximum density at 4 degrees centigrade. This is the variation of the volume and density. So as you can see in the graph that water has got minimum volume and maximum density at 4 degrees centigrade, and it is due to intermolecular hydrogen bonding. And the explanation is because of this intermolecular hydrogen bonding, which is a topic of chemistry itself. And a water molecule is attached to 4 other water molecules by bonding, and with change in temperature bind force changes obviously. So there is a variation of gamma solid and gamma liquid. So if gamma are same, bind and force remains the same. If gamma solid is greater than gamma liquid, then bind force increases. Whereas if gamma solid is less than gamma liquid, bind force decreases. Now there is another concept on a liquid is filled in a container. Container has a gamma for gamma solid and liquid has a gamma for gamma liquid. Then level of liquid will not change with respect to the container if gamma solid is equal to gamma liquid, or gamma liquid is 3 times alpha solid, whereas level of liquid will not change with respect to ground. So here the case is different, that gamma liquid is twice alpha solid or the beta solid. So because here aerial expansion will be used, so that's why from where wave concept of twice 2 factor comes into play. Then we have another discussion video on the introduction of heat. So heat was supposed to be form of fluid initially, but it was experimentally proved that heat is just a form of energy by the famous James Joule experiment, cylinder turning experiment. And in fact, it is a form of energy in transit. Transition means change and generally temperature, but state and phase may also change. Then we have relation between different temperature scales like Fahrenheit and centigrade. So it varies graphically as shown in the figure. Tan theta here is 9 by 5. And for Tk versus Tc graph, tan theta is 1. For Tc versus Tr, the graph passes through the center and the relation is this much. Now we have concept of thermal expansion, which may be linear, aerial or volumetric. Now is the concept of thermal properties of matter. So it's the temperature, and temperature is a measure of hotness or coldness measured by thermometer using different temperature scales. All scales are interconnected, so this is the relation, like we have centigrade scale, Fahrenheit scale, Kelvin scale, Reaumur scale. Lower temperature is 0 degree, 32 degree Fahrenheit, 273.15 Kelvin, 0 Reaumur. Upper temperature is 100 degree centigrade, 212 Fahrenheit, 373.15 Kelvin, 80 Reaumur. And if you take the difference, number of divisions are the number of differences between upper and lower values, so you can analyze that these are the number of divisions. Now there is important concept that for all temperature scales, T minus T lower upon T upper minus T lower is constant for all. Now this can be related to any physical property like pressure, volume, length, or even resistance of a platinum thermometer. So these are the cases, and this is the relation between various physical quantities. Now there is occurs a concept of heat. So heat can be categorized into two forms, either the specific heat or either the latent heat. Specific heat deals with heat needed to change the temperature. Latent heat corresponds to heat needed to change the state or the phase. So specific heat is given by delta Q is equal to ms delta T. M is mass of the body, S is called specific heat capacity, and delta T is the change in temperature. So from here we can analyze the dimensions of S as M0 L2 T minus 2 Kelvin minus 1. SI unit as joule per kg Kelvin, other unit as calorie per gram centimeter. Specific heat of water is 1 calorie per gram per degree centigrade. For ice we have 0.5 calorie per gram per degree centigrade, and for steam it is about 0.42 calorie per gram per degree centigrade. Now there is important discussion that during melting or boiling temperature is constant, so delta T is 0. So from here specific heat comes out to be infinity. So always do remember, if temperature is constant in those processes, specific heat tends to infinity. So this question has been asked many a time, so it's an important point of discussion. Now let us, yeah. There is another derivation of Newton's law of cooling. I have discussed this earlier. So using this we can draw the graphs. There is a concept of regulation. Then there is a discussion on moment of inertia, and this is the indicator diagram. Then we have another question based on elasticity. We have a string of length L and it expands through length x, so we need to find the work done. So here we use the expression for delta L. From here we calculate x, so we calculate force as a function of x. Here force, internal restoring force, will be a variable, depends on x, so work done will be integration f dx. So if we integrate the above expression, work done comes out to be ay by L delta L by L whole square. So this is the work done. So this is how we can calculate the work done by the restoring forces. Then is another discussion on work done by a gas. So it is given by integration PdV, and after solving we get this result. Then is the stress strain curve analysis for a general material. It varies like this. Then we have another revision DPP for mechanical properties of solids. Stress and strain, basically dimensions of various terms. Here also, then here is SI unit of the various terms. Then we have another discussion on stress strain curve for various graphs. So from the graph you can see that theta 3 is greater than theta 2 greater than theta 1. So tan theta 3 will be greater than tan theta 2 will be greater than tan theta 1. So elasticity corresponding to third will be greatest and first will be lowest. So this is the analysis. Then there is important discussion कि याद मत करो, आप केवल फोकस करें. होता क्या है कि जब भी हम कोई चीज़ सीखते हैं तो हमारा मन जो है वो पास्ट और फ्यूचर में उलझा रहता है, जबकि प्रेजेंट में होना बहुत ज़रूरी है. और प्रेजेंट में आने के आ सकते हैं आप जब आपका फोकस प्रेजेंट पे हो. तो पढ़ने के लिए सबसे इम्पोर्टेंट है कि आप प्रेजेंट में होने चाहिए. पास्ट और फ्यूचर की जो इमेजिनेशंस या एक मेमोरी स्टिकिंग है, जस्ट यूज़ देम टू अटैच और टू लर्न न्यू थिंग्स. आप देखें कि हमारा जो माइंड ब्रेन सिस्टम है वो अपने आप में एक ऑटोमेटिक मेमोरी सिस्टम है. एट एवरी इंस्टेंट आपके माइंड ब्रेन सिस्टम में इंफॉर्मेशन रिसीव हो रही है और उसको यूज़ करके आपका माइंड ब्रेन सिस्टम अपडेट हो रहा है. तो अगर आप फोकस्ड हैं तो जिस चीज़ पे आप फोकस करेंगे वही इन्फॉर्मेशन आपके माइंड ब्रेन सिस्टम में अटैच होगी. आप सीख पाएंगे। इसको टेस्ट करने के लिए अपने आप से पूछें कि अभी 2 मिनट पहले आप क्या पढ़ रहे थे। सो आई थिंक यू विल बी एबल टू कनेक्ट कि जो भी आपके साथ हो रहा है उसका एक बैकअप आपके माइंड ब्रेन सिस्टम में बन रहा है। और जब आप देखें कि ये जो हम टेस्टिंग लेते हैं किसी बच्चे की, या जो एग्ज़ाम होता है, एग्ज़ाम का पर्पज़ ही आपका रिटेंशन कैपेसिटी चेक करना है कि आप आपके माइंड ब्रेन सिस्टम में जो इन्फॉर्मेशन स्टोर है उसको समय पढ़ने पर रिटेन कर पा रहे हैं कि नहीं। तो एक बेसिक सा टेस्टिंग मैकेनिज्म रखें, जब आपने पढ़ लिया तो चेक करते रहें कि वो रिटेंशन आपका कितना है। तो उससे आपका कनेक्शन बनेगा माइंड और ब्रेन के बीच में, और बेहतर तरीके से आप रिजल्ट ला पाएंगे, एग्ज़ाम में बेहतर परफॉर्मेंस दे पाएंगे। Then is another discussion on some graphs related to PV graphs related to various quantities. Then we have another discussion on mechanical properties of solids, in which the first thing is introduction, then is stress strain, Hooke's law, modulus of elasticity, stress strain curve. At last we have applications and 3 laws. So the important discussion point here is that rigidity is concerned with elasticity. There is the relation. Then is a stress strain curve for a substance. Then something related to stress, scalar quantity, SI unit, CGS unit, types of strain, stress, 3 types: longitudinal, shear or tangential, volumetric or hydraulic. Then we have a concept for longitudinal stress and strain. Then certain points related to stress, its a scalar quantity, dimension, unit वगैरह are given. Then dimension of stress and strain. So these are certain points. Then we have a discussion on the longitudinal force acting on a body, stress strain graph, calculation based questions on work done by the force. And this is again stress strain graph. Then we have another qualitative discussion on certain functions of the mind brain system, like memorization. For that we have used the concept of external force in a drop, excess pressure in a drop. Then in a bubble, in a drop it is 2T by R, but in a bubble there are 2 surfaces, so that will be 4T by R. Then there are certain questions based on pressure. So pressure in case of a liquid interface is given over here. Now there is a discussion on algorithm regarding myself. So I am a 2007 batch alumni of Government Engineering College, Pantnagar, Uttarakhand. I did my BTech from Information Technology from Government Engineering College, Pantnagar, Uttarakhand, and I got state rank 219. I gave exams IIT, JEE, AEEE, UPTU. So in AEEE or JEE main it used to be at that time. I got state rank 219 in Uttarakhand. So this is what I have achieved. I am an author also. I am a YouTuber also. I'm a singer also as a part of my hobby. So this is what I am done with. You can search my name Acharya Vishvendra on Google, Flipkart, Notion Press, Amazon. I have composed so far 215 books. These are available on Amazon, Flipkart, and Notion Press. And on my YouTube videos, YouTube official channel with the name Acharya Vishvendra. I think more than 9,500 videos are uploaded till now. And if you search for Vishvendra sir, I started a company with the name of OST, or Optimal Success Trajectory. So I think I have composed more thousands of videos with the name Vishvendra sir. You can search on YouTube Vishvendra sir, and there are thousands of other videos available before starting my official YouTube channel Acharya Vishvendra. And coming to the Instagram, I think I have uploaded more than 3,900 reels based on basically most of the reels are concerned with the physics for JEE NEET. Some are based on education psychology, some are based on neuroscience, so a mix of them, but most of that is concerned with the physics for JEE NEET. Then coming to X or Twitter, I have I think tweeted more than 12,000 tweets. These are available on my official channel with the same name Acharya Vishwendra. Then coming to your Pinterest, I have uploaded a lot of videos on Pinterest itself, and all these domains, all these my work is available on online. You can search my name, Acharya Vishvendra Kota, in any search engine like ChatGPT, Grok, or any AI. It will list my work. So I have more than 10-year experience of working as a physics faculty in reputed coaching institutes of Kota and Delhi. So this is a brief summary of what I have done. Then we have another discussion on preparing for JE. So certain things are of concern. The first is class notes, then is NCRT, then is NEET PYQs, and then are the modules. So you should use all of the 4 resources optimally. Then is a discussion on pure rolling on horizontal surface, concerned cases. Then we have a solid fluid interface. Then here is a discussion on free energy, concept of surface energy over here. So work done into change in area. From here we can find the pressure, excess pressure, conditions for that. Then we have another concept for oil and water and negative potential energy concept, cube based problem for fluids. Then attraction repulsion concept of surface energy, air fluid interface. Then we have a worksheet based on Pascal's law. So here we need to find relation between forces, acceleration, velocity as a function of time, graphical analysis, Vt graph, xt graph, pressure is scalar or vector, dimension of pressure into volume, dimension of pressure by volume. Then we have another worksheet on the pressure. It's is it a scalar or vector, dimension, SI units, CGS, various units. Then comparison of pressure at various points as given in the figure. Then pressure difference in a rotating tube. Then we have another worksheet on pressure in a rotating tube as a function of x, graphical variations with variation with d. Pressure based problem on rotating tube problem, pressure at A, B and C, pressure difference. Then a YouTube based problem, finding height difference, expression of height difference as a function of G. This question has been asked this type of JEE Advanced Physics. Then we have another worksheet on calculation of pressure at various points like they here. Then we have another worksheet on density itself, as you can see over here. Then we have another worksheet based on discussion of pressure, like its dimension, SI unit, 1 Pascal is equal to 1 atm is equal to 1 bar is this, 1 atm is equal to this torque. Then a numerical problem based on calculation of pressure at various points, like pressure at A, then graphical variation of pressure with height, graphical variation of pressure with density, then falling freely, if the container falls freely, calculation of pressure, then pressure at A if it is accelerating upward, then accelerating downward case. Then is another discussion on stress strain curve for a substance. It's given over here. So here first question is find Young's modulus. So Young's modulus means the range in which graph is a straight line. So here it is a straight line, and we know that slope is given by Young's modulus. So it is a stress by strain. So we can see that corresponding to this point, strain is 10%. And stress is 5 into 10 is to power 5. So using this we can calculate Young's modulus as 5 into 10 is to power 6 Newton per meter square. Then we need to find proportional limit. So proportional limit is the point up to which graph is a straight line. So it corresponds to point A. Then elastic point. So the next higher point corresponds to elastic limit, which is B. Then it's ultimate stress. So ultimate stress corresponds to the maximum stress, which is given by here. Here coordinate is 20 and unit size is 10 is to power 5. So the value corresponding to ultimate stress will be 20 into 10 is to power 5. Then is a stress at fracture point. So fracture point is given by E. And we can see that graph corresponding to this corresponds to a point having numerical value 16 and unit is 10 is to power 5. So stress will be 16 into 10 is to power 5. Then is a strain at fracture point. So we can see that strain at fracture point is 45%. So that will be 45% or 0.45. Then strain at ultimate stress. So from here we can see that strain at ultimate stress is 40% or it is 0.4. Then is strain at elastic limit. So elastic limit correspond to point B and strain is given by 15%. So it is 0.15. Then we have concept of dimension of strength. So it is dimensionless. Stress, it has got F1 L minus 1 T minus 2. Stress by strain same. Young's modulus same. Bulk modulus same. Shear modulus same. Energy density same. So all of these have same units and dimensions. Then we have another discussion point on density. Density and pressure, obviously.